So now that we've talked a bit about reactive programming as a set of concepts, let's talk next about the structure and functionality of the Java Completable Futures framework. And we'll talk about how it works and what it does and why it does what it does the way it does it. So the Completable Future framework is an asynchronous and quasi-reactive parallel programming model. And you'll see it actually can be used for reactive programming, although there are other more fulsome ways of doing it by using reactive streams frameworks like RxJava or Project Reactor. But it helps to understand Completable Futures first, because the other stuff makes a lot more sense when you understand Completable Futures. So to describe what Completable Futures is and how it works and why it's a win, let's consider we have a web crawler, not unlike what you're doing for your assignments, that's synchronous. In other words, one thread of control. Everything goes by blocking operations. And these are the steps that you would do. You would get the start page, then you would count the number of images on that page, then you would count the images on all the hyperlink pages reachable from that page, and then you would combine the results to create the total count. And the time that you need to do this is the sum of each of the steps that run sequentially. No real surprise there, right? That's kind of obvious. Now let's talk about Completable Futures. So the idea of Completable Futures is to take that set of tasks that we did in a sequential sort of pipeline, if you will, and allow it to be split up into smaller subtasks that can run asynchronously and then be triggered when something completes. So here what we would do is we would get the start page asynchronously, and when that is complete, that triggers tasks 2 and task 3. So now we're going to count the images on the page asynchronously to counting the images on all the hyperlinked pages asynchronously. These things can now run in parallel because we don't have to be restricted by the linear flow. And then after both of these tasks finish running asynchronously, when they complete, we combine the results together. And we could do that either synchronously or asynchronously. It's honestly probably easier to do it synchronously because it's so fast to add 2 results, but you could do it asynchronously as well. And asynchronous here really means runs in other threads of control as part of a pool of threads like the common fork join pool or some other threading model. So that's the basic idea. Split your tasks up into chunks, let those chunks run in some kind of asynchronous manner, and then combine the results together. And you can see this is basically like a data flow diagram. Here's what the code might actually look like, and we'll look at this code later. You can take a look at this code here at this link. And what we can do is we can make a call to an a Completable Future async factory method called supply async. It'll get the page. It gives back something called a Completable Future. That Completable Future is then used for the other computations when that Completable Future completes. Then we do other asynchronous operations, and they give back Completable Futures as well. And when those asynchronous operations complete, then those Completable Futures are triggered, and then they combine the results together and sum them up. So the way to think about this is these asynchronous operations can be forked, such as calling supply async, chained, such as doing then apply async followed by then apply, and then joined together. And so you're basically kind of programming an implicit graph of asynchronous tasks that are being managed under the hood by lower level Java concurrency mechanisms, usually but not limited to the common fork join pool. The cool thing about Completable Futures is it allows you to have asynchronous computations that look like synchronous computations, in the sense that what you invoke something that runs asynchronously, and when it completes, the next method, called a completion stage method, in the chain or pipeline is automatically called. So it looks kind of like synchronous programming, but it's actually running asynchronously. And it's super cool, and it's also implemented in a very clever way, which we'll talk about later. These async operations can run in a thread pool, or almost always run in a thread pool, which is either the common fork join pool, some other fork join pool, or some other type of either predefined or user-defined thread pools, like a fixed size thread pool or a cached thread pool or whatever kind of thread pool you might want to make. The guy who was the fork join blunder guy, he could plug his thread pool in if he was so desired to do that. And the time needed to perform these tasks depend on how well the tasks can be parallelized. And so this is basically something that's known as Amdahl's law. And Amdahl's law is just a fancy way of saying that you can only get a win from parallelism to the extent that you have things that run in parallel. And if a lot of your program is going to be sequential, then throwing a lot of parallelism at the problem isn't going to make things any better, or won't things make things much better. So it's not just a good idea, it's the law, right? So Amdahl's law. Now, the Java Completable Features framework resides in one public class with a ridiculously large number of methods. There's like 60 plus methods, and they keep adding new ones all the time. And I've made your life a little easier by grouping the methods together according to their category. They're factory methods that make things. There's basic methods that are inherited from Java Future. There's things that handle exceptions. The bulk of the methods are these so-called completion stage methods. And then these really cool methods, which are very hard to program without wrapping them up in other kinds of objects, which are called arbitrary arity methods. And we'll talk about those things as well. Now, the other cool thing to remember, and we'll see some examples of this as we go through this portion of the course, you can take completable features, you can take sequential streams and functional programming features in modern Java and combine them together in very nice ways. And actually, this example here shows how to do this. And your programming assignment number 4 will give you a chance to do this as well. So you'll combine completable features with Java sequential streams. It's overkill to combine Java completable features with parallel streams. And we'll talk more about that later. As with parallel streams, there's no need to put synchronization or threading in your programs directly. You don't have to spawn threads. You don't have to do locks. Typically, of course, there's some circumstances where that might be necessary. But again, you can wrap things up, and you can use the Java class libraries like concurrent hash map if you need to do that. So that's the end of a quick overview of the Java Completable Features framework.